Okay, so today I'm going to be talking about pollination biology, and Garit and I came up with this title. We thought we'd put a little culture in it, beyond horticulture, and you'll notice that I've added a lot of terminology throughout the talk. Some of the biological terminology that comes from the Greek and Latin words. And I'm going to avoid saying every Greek word here because I didn't have a chance to practice with Thamus beforehand, so I'm terrified that I'd pronounce everything wrong. So for pistachios, they are a dioecious crop, and that means that there's two houses. It comes from the Greek word for house, and we have male and female flowers on different trees. They're anemophilous, which means wind-pollinated, and it comes from the Greek word for wind. And this is in contrast to the insect-pollinated crops such as almonds, which are entomophilous, and that comes from the Greek word for meaning cut into pieces or segmented for insects. So for pistachios, the male and the female flowers are on different trees. The female flowers we refer to as pistillate flowers, and the males are staminate flowers. Now there's some similarities between the male and female flowers on pistachio. Neither have petals or nectaries because they're not trying to attract insects. And the flowers are borne in inflorescences along a rachis. The female flowers are about 2 to 3 millimeters long, and there's around 300 on average flowers in each inflorescence. Each stigma has 3 lobes. The male flowers borne on the male trees are the pollen source for pistachios. Each grain of pollen is approximately 20 micrometers, and there's around 5 anthers in each male flower. Now, one of the interesting things about the pollen of pistachio compared to other crops is that it tends to clump. And some of the researchers that have worked with electrostatic pollination for supplemental pollination have found that this is one of the challenges in terms of supplemental pollination in pistachio, that clumping characteristic. Also, some of the folks that have studied the wind-borne aerodynamics of pollen have noticed that the pollen of pistachio behaves a little bit differently with some other crops in terms of how it's dispersed. So with pistachio, not all of the buds and not all of the flowers open at the same time. And what we'll find is that the apical buds tend to open earlier than lateral buds, but also the more basal flowers within an inflorescence tend to open earlier than the more apical flowers within an inflorescence. This is called acropetal flower maturation. The pollen is transported by wind for approximately 20 meters. This work was done in the late 1990s, and what they found is that about 20 meters or 66 feet is about as far a male plant can be from the females in order to have adequate dispersal of pollen. This established the minimum distance and also gave rise to our current system using 24 female trees per 1 male tree. And of course, we have this established as a planting protocol of planting the males every 5th row, every 5th tree. So one of the first limitations we find in terms of setting a good crop is the longevity of pollen. As soon as the pollen is released from the anthers, it starts to desiccate in the field. And somewhere around 12 to 18 hours after release from the male flower, the germinability or viability of the pollen has decreased significantly from where it is at about 1 hour after its dispersal. So the pollen actually starts to rupture, there's a breakdown in the cells, and so really the longevity of pollen that's released is within the day that it's collected. Now I want to be clear that researchers who are doing breeding work for pistachio, as well as those that are doing supplemental pollination work, they have to actually take special efforts in order to preserve the pollen and ensure its longevity. So the majority of pollen is shed over a 2-week period. That's the week of the male bloom. However, the majority of the pollen shed is in just 7 to 8 days. Also, if we look at the main timing of pollen release in pistachios, and you look at a given day, over 73% of the daily pollen is actually shed between 9 a.m. and 11 a.m. So most of the pollen is actually coming out in the morning. Now that pollen viability is critical to both nut set and nut quality parameters. So first of all, the higher the pollen variability or viability, the higher your total yield or nut set. Also, the pollen viability affects the number of blanks. So the higher the pollen viability, the higher the number of blanks or percent blanks that you get in your grade sheets. And when you think about it, non-viable pollen is just dust floating around in your orchard. And remember that as a key fact when I start talking about dust and parthenocarpy. Pollen viability also affects the split rate. So again, you need really good viable pollen in order to get the splits. Wind is also a key factor. You need wind at over 1 meter per second, and the higher the wind speed, the more pollen dispersal you get. The older the inflorescence is, like the longer it's open, the more pollen that is captured by the stigmas. Also, the windward flowers tend to receive more pollen than the leeward flowers. These unclumped pollen grains, they actually float around in somewhat of an erratic trajectory around the flowers, and then they tend to accumulate on the leeward surfaces of the flowers. The terminal florets tend to capture more pollen than the lower flowers in an inflorescence. And those that looked at the physics and the aerodynamics of pollen dispersal mentioned that the climatic conditions in the morning, in terms of the atmospheric conditions, create the perfect conditions for dispersal gradients. So not only have the flowers been adapted over time to release pollen in the morning, those are also the perfect atmospheric conditions. They talked about, the air densities, et cetera, in the morning. That was kind of over my head, but those are perfect for pollen dispersal. Once the pollen is released from the male flowers, it's deposited on the stigmas. There, it takes about 2 hours to germinate. Now, despite the loads of pollen that's in the air, only 14 to 15 pollen grains are needed per flower in order to get fertilization. Too much pollen, on the other hand, can cause flower abscission. So the pollination, actually, once the pollen lands on the stigma, it actually starts stigmatic degradation. So once the pollen gets to the stigma, it kind of starts the end of life of that stigma. Within about 24 hours of the pollen getting to the stigmatic surface, it'll go to the base of the style, and about 48 hours later, it gets to the nucellus. So despite 100 pollen grains getting to the stigma, really less than 2 are actually doing the job when they get down to the actual embryo sac. The pollen germination will vary with flower age, and interestingly, the pollen germination and the pollen tube penetration is highest on 2 and 3 day old flowers. Once the flowers are 4 days old, it doesn't work so much in terms of the pollen germination. 3 day old pistils, they produce mainly misshapen fruits, and the pistils pollinated on day 4 mostly abscise before maturity. That leads to the mention of the peak pistil maturity of any given flower is in the first and the second days. So as a farm advisor, every year around bloom, starting with almond bloom, we get calls about supplemental pollination. So a lot of times, especially when the prices are high, growers consider doing supplemental pollination to try to get a higher yield. And I've studied and done some studies on almonds as well, on supplemental pollination, and I've read the literature on supplemental pollination on pistachio. And some of the work was done usually late 90s, early 2000s, and there was quite a bit of work done here in the southern San Joaquin Valley. Some early studies with electrostatic pollination found that 12.7% yield increases were observed in an orchard where the male and the female bloom was asynchronous. And in that study, they also got 28% more splits. So that was a significant benefit from supplemental pollination. But the authors did caution that higher pollen levels may cause reduced yields. And then when I went and I read through the literature from other studies, there was another study that showed a benefit to supplemental pollination in one plot. This was, I believe, in a Kern County plot. But in a second plot in the same year, there was no significant effect of supplemental pollination. And when the same researchers repeated those studies the following year, they had no effect in either plot. So it shows that there can be some inconsistencies to supplemental pollination. Steve Sibbett, my predecessor here in Tulare County, did a study back in 1993 in a 9-year-old Kerman Peters orchard. And this orchard had a history of poor crop. And this work is reported in a newsletter, and they found that there was no effect of supplemental pollination on blanks or yield. I also found another paper that showed that supplemental pollination in their studies reduced yield. And you have to remember, supplemental pollination, if there's too much pollen on the stigmas, you can get abscission of flowers. This paper was so bold as to say that they recommended it for thinning and on crop to mitigate alternate bearing. So that shows that there is a risk involved. That said, there is a place, a time and a place for supplemental pollination. It may be beneficial in situations where there's isolated plantings with limited pollinizers available, or in years where you have an asynchrony of male and female bloom. This will typically happen in years where we have low winter chill. Supplemental pollination may be a benefit if the normal processes are not going to work. So for almonds, that would be if there's a bee failure. So for example, I did work with supplemental pollination in almonds where we applied the pollen with an electrostatic sprayer. If we did it and allowed the bees full range of the orchard, we had no effect on yield. But if we covered the inflorescences to keep the bees out, we actually got a bump of yield. So without the bees, the supplemental pollination worked. And it's the same thing with pistachios, even though it's a wind-pollinated crop. If you have a failure of the normal situation or an asynchrony of bloom, the supplemental pollination can come in and have a huge beneficial effect. Now that said, to do supplemental pollination, there is some research being done in order to make it more cost-effective. One of our collaborators in Spain for some of the work that Louise and I have worked on with olive, mechanical harvest of olive, Sergio Castro Garcia, one of his group has worked on mechanical harvest of pollen. So the goal is to apply the harvest technologies that we use, like trunk shakers, but apply them for capturing the pollen, either shaking off the male inflorescences or the pollen itself. And when you think about it, it's a little bit different than mechanical harvest because you're using male trees that are larger, and also you're shaking those trees during bloom when there's no leaves on the trees to dampen the transmissal of vibrations. So they're trying to optimize conditions for harvesting the pollen. And one of the thoughts that they mention is that this might make an opportunity to have plantations of just pollinizers, so you can effectively grow just the male trees and collect the pollen. And of course, as I mentioned, there are techniques for ensuring pollen longevity. And Sergio sent this picture of one of the things they're doing. This is one of the low-tech stick whacking a branch, but a little bit of a vacuum suction, and they can capture that pollen. And then this could be used for electrostatic pollination or even just blowing the pollen in the air. So one other thing I wanted to mention, and I don't think it's super pertinent, I know it's not pertinent in California, but that doesn't mean that it's not pertinent globally, and that is that the male parent can affect the nut characteristics. And there is information in the literature, and this is from California in 1980, but low fruit set, reduced percent splits, and reduced nut size can result from Pistachio atlantica pollen. So you wouldn't want rogue male P. atlantica trees out there. A curiosity that I have, as a scientist, is that there is a lot of chinensis, Pistachio chinensis trees actually grown as ornamentals, and I don't know if there's any effect of chinensis pollen, on pollination of P. vera. So that is a curiosity. So in short, pollination is a process, it's not an event. It requires the maturation of the female flowers. The pistils are most receptive between 1 and 2 days old. You need viable pollen, and as it desiccates over the course of a day in the environment, it loses its viability. We need pistils that are receptive, and we need wind to transmit that pollen. So in the end, the next question we get is what causes blanks? And of course, some years that can be a real problem. There are 2 processes that are responsible for blanks: parthenocarpy and stenospermy. Parthenocarpy is fruit development without fertilization. With stenospermy, that's post-fertilization embryo abortion. And one of the most frustrating things about blanks is you won't know that you have blanks out there until a good 10 weeks post-bloom. And that's because with pistachios, the pericarp completely grows and expands before the kernel starts to grow. And so you get to about 10 weeks post-bloom, and then you can do a cross-section of the nuts, and you'll look, and you'll see that some of them will be blank, and you have just this spongy tissue there, which is the funiculus, which is really just the attachment between the mother plant and the growing seed. So there's multiple outcomes for any given flower. For example, the positive outcome that we all look for is fertilization and fruit development. But some flowers might abscise. That can happen from too much pollen. Or you can have pollination and stenospermy, where an embryo develops and it just doesn't make it. It aborts for some reason or another. Also, we can have no pollination, and parthenocarpy can happen. This can happen if dust, for example, falls on the stigma, which I'm going to talk about next. And of course, we can have no pollination, nothing happens, and just abscission occurs. So researchers were interested in whether dust might be responsible for parthenocarpy. This is a photo from Louise Ferguson showing flail mowing during bloom in a pistachio orchard. And several years ago, I believe around 2017, 2018, Louise had a postdoc working for her, Lou Tsang, and she's now at Oklahoma State working on pecan, and I still have the pleasure of collaborating with her with pecan work. But Lou did this really neat work on pistachio, looking at whether pollen can induce, dust might induce parthenocarpy on pistachio. And what they did is they took individual florets, and they dusted them with either pollen, just to try to achieve normal nut set as a control, or dust that was impregnated with herbicides. And they had 2 different herbicides in this treatment. They found that the dust induced stigma wilting, and they had 32% fewer nuts. Basically, it caused problems. It caused blanks. And then the dust plus herbicide They actually did this electron microscopy, and they could see that it damaged cells on the surface of the stigma. They got less than 5% nut set, and then 100% of those nuts actually dropped by harvest. So this work had a really important take-home message, was that to minimize blanks, you want to minimize dust-inducing operations during bloom. So if you have that option, it's a good idea to not do flail mowing or reduce operations that can kick up dust during the bloom. So then the last topic that I want to cover is that the main goal in terms of pollination is to try to achieve a synchrony of male and female bloom. And we've had some wonderful releases of cultivars and male pollinizers from the Pistachio breeding program. Much of this work was done by Craig Carlson and Dan Parfit, and also Joe Moranto contributed to that work as well. One of the new varieties, Gumdrop, has a very early bloom date, March 28th, and they've selected a pollinizer and released it called Tejon, and that is an early blooming male that blooms in late March. Oops, I'm sorry, how do I go back? Golden Hills and Lost Hills are somewhat early, the April 7th bloom date, and their preferred pollinizer is Randy. And Kerman, of course, is the later blooming variety, and it blooms April 12th. Peters is the standard pollinizer. However, they've released Famoso, an alternate pollinizer for Kerman. And Famoso was selected to better overlap the receptivity of Kerman female in both the low and the high chill years. So this is a new option as a pollinizer for Kerman. But one of the main problems that we have in the industry is when we have asynchrony of these male and female trees. And that tends to happen in low chill years, and what tends to happen is that the males come later than the females. And so that's where we have the issue, and we end up with a discrepancy of bloom. And in these two low chill years, they looked at the bloom dates of these varieties and their corresponding pollinizers in 2014 and 2015. And what they found was that the males were between 4 and 9 days later than their corresponding females. So if you look at, for example, Gumdrop and Tejon here, we had a March 22nd bloom for Gumdrop and a March 31st date for bloom for Tejon. So that was a really big offset year. So what can a grower do to try to deal with these low chill winters? Well, one option, and actually I saw this done by one of our grower cooperators in Kings County, that is kind of cool. We don't have scientific data on it, but it was just a cool thing he did. He cut branches of alternate pollinizers, and he put them up in pruning towers above orchards. And so he actually had kind of extended the types of pollen that were out at a time. And I think that that's kind of a really neat idea. Alternately, on a more formal level, you could plant supplemental male pollinizers in the field. And some of these options, for example, if we look at Kerman, on a high chill year, Peters will work good. On a moderate year, Famoso is your recommended standard male pollinizer, and a supplemental male would be Peters. But in a low chill year, Randy might be a good supplemental pollinizer with Famoso as your standard, just to help cover that bloom. Now let's look at Golden Hills and Lost Hills. In a high chill year, Randy is your standard. You could supplement with Famoso. Golden Hills, your standard would be Randy. And in a low chill year, one might rely on Tejon as a supplemental male pollinizer. So you can actually put some alternate male pollinizers in orchards to help cover those years where the chill creates an asynchrony in bloom. So I'd just like to summarize the topics that I covered. First, the duration of bloom. Remember, we have about a 7 to 8 day bloom period. About a 2-week bloom period. The majority of pollen is shed 7 to 8 days. Most of the pollen is released in the morning. Pollen has a limited longevity. Once it's released into the environment, your pollen is lasting hours, not days. The stigmas are most receptible for 1 to 2 days. The older flowers, if they're pollinated later, they tend to result in aborted nuts or misshapen nuts, etc. Supplemental pollination can be of value, but it's mostly going to be of value in the years where you have asynchrony of bloom. And it does come with the caution that too much pollen can cause flower abscission, so that there is a cautionary tale to it. Dust does induce parthenocarpy. So for management, reduce dust-inducing operations in your orchard during bloom. Also, choose the appropriate pollinizers, and you can consider putting supplemental pollinizers in orchard in order to cover the female bloom better and avoid issues of asynchrony. Okay, with that, I'll take any questions.